Hey everyone, in today's video, we're going to be solving the problem maximum subarray on Leetcode. So the question says, given an integer arrays, find the subarray with the largest sum and return its sum. Right. So let's say what the question is saying firstly. So if you're given an array over here like this, right, you need to find the maximum subarray. Now what does that mean? You need to take any you can take any amount of subarrays in this, right? You can have -2 as a separate subarray. You can have -2 and 1 as a separate subarray. You can have -2, 1, -3 as a subarray. You can have 1 as a subarray on its own. You can have -3 as a subarray on its own. You can have 1, -3, 4, -1, 2 as a subarray its own. And you can have anything, right? You can have the whole thing as a subarray on its own as well, right? You need to find the subarray that will give you the maximum sum, right? So you need to find the subarray that will give you the maximum sum. So if I have something like this question, right? If I have this question, 4 -1, 2, and 1 is gonna give you the maximum subarray which will give you the maximum sum, which is 6, right? So 4 plus 2, 5, 6 plus 1, 7, -1, 1, right? So this is gonna give you the maximum subarray, and this is the output for this question, right? I hope you understood the question. Again, let me just give you like a very small example. Let's say you have an example like 2 and -1, and right, so over here, 2 will be the output because 2 will give you the maximum sum in any subarray. So if 2 on its own will be one small subarray, and that will give you the maximum sum, which is equal to 2. If I have something like 4, 5, -1, -2, 8, right? In this case, 4 and 5 will give me the maximum subarray, which is 9, right? If I do any kind of computation over here, oh no, sorry, 4 and 5 won't give me the maximum subarray. I'll get my maximum subarray from, I think, this one, right? Even keeping the negative values. If I do 5 -1, 4, -2, 2, plus 8 will be 10, right? Plus 8 will be 10. And I think if I add 4 also over here, it'll give me 14. So this would be my maximum subarrays. The whole array would be my maximum subarray, which will give me the most maximum sum, right? So this is what the question is, guys. Now, how are we going to solve this? So I won't explain you the brute force approaches. I'll just write down the code for you guys. But I think the brute force approaches are pretty simple to, brainstorm on yourself and figure out how they're going to work out. So I hope you guys go through them on your own. I'll write the code down over here for you guys. Once you can just go through it and just see if you're writing the right code or not. But I'm not going to explain it. So just be cautious about that. And if you guys do feel that you don't understand what the brute force approach is, how it's working out, let me know in the comments. I'll just write down the code for you guys, like a pseudocode for it, so that you guys can just go through it and you can just check what your logic, if your logic is right, or if you just want to check if you're writing the right code or not. I'll just write it down for you first. So let's start with the very most unoptimal approach, which is like the brute force approach. So firstly, we'll keep a maxi equal to minus infinity. Will run three loops, right? One is I, which will go from 0 to n minus 1. My second loop, which is j, will go from I to n. I'll initialize a variable sum, which is equal to 0. Then inside I'll run a loop k, which will go from I to j plus 1, right? And then I'll add s plus equal to my, what is this, nums, right? To my nums k. And lastly, over here, I'll do this maxi equal to max of maxi comma sum. And lastly, I'll just return maxi over here. Return maxi. So this is what the code is for the most unoptimal approach. Just write this again. I'll just write it here, right? Return maxi. So this is the most unoptimal approach, which has a time complexity of O of n cube and a space complexity of O of 1, right? Now, moving forward, right? I'm just telling you guys the code and time complexity, so that if you're ever asked in an interview, you don't jump to the most optimal approach, right? You need to give them the most brute force approach, and when asked to optimize it, you give them the optimal approach, right? So this is the most unoptimal approach. Now we'll optimize it, right? So for optimizing it, what we'll do We'll use two loops now instead of three. Firstly, we'll keep a maxi equal to minus infinity. We'll run a loop for I in range n. I'll keep a sum equal to 0. Then I'll run a loop j in range I to n. Now, what I'll do is I'll increment my sum value equal to, okay, nums of j like this. I'll check with maxi over here, maxi comma sum, and in the end, I'll just return maxi like this, right? So this is the second approach, which is a bit more optimal than the first one, and this will give you a time complexity of O of n square and a space complexity of O of 1, right? So these are the two approaches. You need to tell the interviewer first when asked to optimize the code. So if he gives you the very first, if he tells you the question firsthand, right, you give him the most brute force approach, which is the O of n cube one. If he asks to optimize it, then you give him the O of n square one. And later on, lastly, when he asks you to optimize the time complexity, which is O of n square even more, then you give him the most optimal one, which would be the Kadane's algorithm, which is the topic for today's video. Okay, so let me just rub all of this now, and let me just explain how Kadane's algorithm is going to work. Okay, so before we go on to Kadane's algorithm, I want you guys to understand a small concept. Okay, so let's say we have two small subarrays, right? We have two small arrays, not subarrays. We have two small arrays over here, like -2, 2 and -1, and we have 2 and +1. Okay, now I want you to understand this. When you have a subarray like 2 and -1, what is the maximum sum you can think of you'll have over here? In this case, it would be 2. In this case, again, it would be 2, right? If I give you a subarray like -2 and -1, in this case, it would be -1, right? And if I give you something like -2 and 1, in this case, it would be 1, right? Now, keep in mind these things. Like, what are the most optimal ones? I'll just write it above them in red. This subarray will give me a maximum sum of 2. This will give me a sum of 3. Sorry, not 2. 2 plus 1 will be 3. This will give me -1. And this will give me 1. Right. Now, I want you guys to understand one small concept before you jump onto Kadane's algorithm. Keep it in your mind when I explain you the flow for Kadane's algorithm. Okay. Now, I want you guys to understand one thing. If I have a subarray of my 2 and -1 right now, right? And let's say if I reduce my sum, right, I have to add the values, right? Let's say I run a loop. Let's say I run a loop I over here, right, which is going to go till the end of the array, because we're going to only have one loop in the whole code, right? So what I'll do first is my very first step would be to add I to sum, right? So I'll keep a variable sum and add it to I. Now when I add sum will be equal to 2. For initially it will be 0, now it will become 2. And later on, what I'll do is I'll compare my sum with the maximum amount. Initially, I'll keep a maxi, which will be equal to, minus infinity. I'll compare it in the second step. Maxi is equal to sum, comma maxi, right? Which will be equal to 2, right? Now, this is actually what Kadane's algorithm is. This is the first step. This is the second step. Okay. Now, the third step is the most important one in Kadane's algorithm. Right. I'll tell you what it is first. The third line of code is going to be if sum is less than 0, make sum equal to 0. Okay. Now, the very first thing is why. Right. Why do we do this step? Okay. And this is the most big question of Kadane's algorithm. Right, and this is the whole code actually. The first step, the second step, and third step, that's it. There's nothing more in the whole code, and this is it. Right, now I'll tell you one thing. Let's do a dry run, small dry run. Let's see what's happening with the small question over here, like 2 and -1. What is happening when I run I from 0 to 2? I firstly add it to the sum, right? And then I compare it with maxi, right? When I compare it with maxi, I see that from minus infinity and 2, initially it was 2, and this is minus infinity. Which is greater? 2 is greater. So I won't make any changes. And later on, I won't make any changes to sum. And later on, if my sum is less than 0, I'll make my sum equal to 0. Right. Again, 2 is not less than 0. So we won't change anything to 2. We go to minus 1. We add it over here. 2 minus 1 is going to be 1. And over here, if I get a 1 over here, right, I see that between maxi, which is 2, and sum, which is 1, 2 is greater. So I won't change maxi. And the whole code is done. And the output is 2. Right. Now, let's jump to a question like the third one. You'll understand now what's going to happen. Now, in this case, let me take a different pen. Let's take a blue pen over here. All right, let's cut this out, cut this out, cut this out, remove this. Yeah. Now, let's take this. Now, when my I is at minus 2, okay, I'll add it to the sum over here as minus 2. I'll compare it and change maxi to equal to minus 2 as well. Right. Now, when I go to minus 1, right, I increment my. Now, secondly, now the last step, you have to check over here. If sum is less than 0, we change the sum back equal to 0. So I change the sum back equal to 0. Right. Now, why do we do that? The reason for doing this is I need you to understand, if I have a subarray like minus 2 and minus 1, right? If I have a subarray like minus 2 and minus 1, what all small subarrays I can make out of it? If I have an array like minus 2 and minus 1, the subarrays I can make out of it are minus 2, minus 1, 2, minus 2, and minus 1, like this. These are the three subarrays I can make. Now, which would give me the maximum output? Won't minus 1 give me the maximum output? Right. Now, over here, I want you to understand, when before changing this sum less than 0 and sum is equal to 0, let's not do this for now. For now, let's not do this. And just go to the next step. This is again minus 2, not anything. If I go to minus 1, right, and I add minus 1 right now, what would this do? It will give me a minus 3, right? It's not changing the output over here, right? Adding the two negative values is not changing the output of the code, right? Not changing maxi, right? Which is going to be the main output of the code. It's not changing it. And now, why isn't changing it? It's the basic fundamental property of negative values that the least negative value, like minus 1 over here, right, from numbers 1 to 100, right, we have 1 to 100 increasing values, right? 100 will be greater than 99, which will be greater than 98, and so on. But in negative values, as you know, minus 1 would be greater than minus 100, right? So on. And minus 99 greater than 100, minus 100, minus 98 greater than minus 99, and so on. Right? And minus 1 would be the greatest value out of all of them, right? In negative values, right? From minus infinity to minus 1 is the greatest negative value you can have. And it's a single value, right? It's a single value. Now, if you add the negative values, won't that just decrease the total value of it, right? Isn't minus 3 less than minus 2, which is also less than minus 1, right? You need to understand this concept now. This is the main reason why we change this sub less than equal to 0. Because if we don't change this, the next value which we have, which is minus 1, we cannot never get that as our output, right? We can never get that as our output. So if I have a minus 2 and minus 1 over here, we can never have minus 1 as the output, because our loop would be completed in that one whole run. So if I change the sum over here to 0, if I change the sum over here back to 0, what would this do? My maxi is still minus 2, right? My maxi is still minus 2. Now you already understood that if I add the two negative values, it's not going to give me a greater negative. It's not going to give me a greater value. It's still going to depreciate the value I already have. And when I add minus 1 to minus 2, so if I just have minus 1 on its own right now, won't that give me like this minus 1 right now? Won't that give me a more greater value than minus 2, which is minus 1, right? And can't I just return maxi now as the output, right? So my output for this case would be minus 1, right? So I hope you understand what I'm trying to say, right? If you have, let's say, an array of negative values, right, the a single sub array, let's say I have array of negative values -1, -2, -3, -4. A single sub array with a value is going to have a greater value than the combination of any of those values, right? So if I have multiple sub arrays inside like this, -1, -2, -3, -1, -2, -4, -4, -1, whatever, right? Among all of this, all of these sub arrays, -1 with a single sub array like -1 is going to have the greatest value out of it, right? So it doesn't make sense to add the negative values together. And when it does go below zero, right, it's gonna depreciate the value as a whole. Right, now you're gonna understand even better. Now, if you understand this concept, right, you're gonna understand better when I do a dry run on a bigger problem and see the whole code in first glance. Okay, so I hope you just remember the concept right now. What's happening over here of negative values. Okay, now let's go back to this question. Now let's look at this question over here. Now let's run a loop from I. Let's do a red pen. Okay, let's. My I is over here right now. Right. My very first step would be to add. First let's initialize S, which would be. Let me just write the code down as well. So first step would be to initialize. Your S something like sum equal to 0. Second step would be to initialize maxi equal to minus infinity. Right. Now let's move along and let's see what's going to happen. Now the very first step, I run a loop for I in range n, length of nums. Okay, my very first step is this. I'm going to run a loop from I range length of nums. Very first step is going to be adding the current I value to S. So I'll do S plus equal nums of I, right, -2. Perfect. Second step, the second step is gonna check maxi equal to max of S comma maxi. Perfect. This will be -2. Done. Third step is if sum is less than 0, make sum equal to 0. Done. And the last step would be to return maxi. Okay. So this is what's going to be the code. Now let's see what's happening. First step, -2, right? Added to the sum. We added it. We compared with maxi. We compared it. Now is sum less than 0? Yes, sum is less than 0. So we change sum back to 0, right? But maxi is still -2, right? So if we had an array of all negative values over here, you need to understand that if I had an array of all negative values over here, like -2, -3, -6, or -1, right? -2 would still be my maxi, and if I return it, my greatest value would be -2, right? In this case, not -1. -1 would be the output, but let's just say, let's just remove -1 here. But then -2 would be the greatest output, and we would have returned -2, right? Because the very first time when we add the sum, we have -2 over here. We update maxi, which is equal to -2. Now we're not changing it. And as I told you, that single -2 value is going to have a greater value than the combination of the negative values combined, right? So since that is done, right, I can just move forward now. And if I go forward, I keep on doing this. Later on, when I go to -1, the 0 will be changed to -1. I compare it with -2, and this will change to -1. And later on, we'll just return -1 for this example. But yeah, let's move forward in this code only. Right. So -2, maxi is -2. Right. So if the whole array would just contain all negative values, the very which are lower than -2, like -3, -4, -5, -2 would still be present as the maxi. Even if we add all the values together, it won't make a difference because that single negative value of -2 is going to have a greater value than any combination combined. Right. Now, next step, we update I. We move forward to I over here. Now, again, as I told you, if my I is equal to 1 now, right? If I have -2 and 1, won't the subarray 1 have a greater value than the combination, any combination combined? Because this is a negative value, right? Think about it logically. If I do -2 plus 1, won't this be -1? If -2 on its own will be -2 and 1 on its own will be 1, which will be the greatest value, right? So won't that be the greatest combination, right? That is why we change the sum. If sum goes below 0, we change it to equal to 0, right? Now, once we do that, we add 1 to the sum over here, right? Let's change the color, actually. We'll change 1 over here, right? Now we're going to compare with Maxi. When we compare it with Maxi, we see that from -2 and 1, 1 is greater. So we update this to 1, right? Next step, we move to -3, right? Now, since my sum is greater than 0, we won't change it, because we won't change it, right? Now, when we have 1 and -3, the sum's value goes down to -2, right? The sum's value goes down to -2. Now, I want to again remember the same concept, okay? Because this is the most important concept of Kadane's algorithm, which I'm emphasizing again and again. So, if I have 1 and -3, won't 1 on its own be the greatest value, right? 1 on its own would be the greatest value, and we're already updated with the maxi equal to 1, right? Sorry. I already updated the maxi equal to 1. So if I add a -3, it will just depreciate the value of it. And if it does go below 0, right? If it does go below 0, it's not going to make a dent on my code, right? I already have the greater value on my side, which is 1, which is in maxi. So I won't change anything, right? It won't make any kind of changes, right? So now my maxi is still 1. Now I'll change my sum equal to 0 because it's gone below -2. So gone below 0, right? Now I move my I go to 4, right? Now when I go to 4, what I see is that my 4, if I add a 4, I'll have to add a 4 now. Now I see my 4 is greater than 1, so I update this with 4. Perfect. Then, because this is greater than 0, we won't do any changes. We move forward to I. Now when we move forward to I, we see that my I is equal to -1. Now 4 minus 3 is equal to +3. 4 minus 1 is equal to +3. Right. Again, it won't make any difference. Again, we need to have this +3, and you'll understand why we need to have this. We need to have this -1 value in our array. Okay. We have this +3 value. Done. Okay. Now we have still the greatest among this. All of this is still going to be 4. Right. So we have that maxi equal to 4. Perfect. It's not going below 0. We won't change it. We move forward to 2. When we go forward to 2, we increment this to 5. Right. We increment this to 5. Now, did you see something? You saw something, right? You saw that when we added 4, -1, and 2, right, it's going to give me a greater value than the single, subarray of 4, right? And it does contain a negative value, right? So it is important to include the negative values as well, okay? So because this is a subarray, it's not like a single what do you call it, subsequence or something, where you can take any random values like from 4 to 4 and add them. It's not like that, right? It's like a proper subarray. So this is your own subarray right now, which is going to have a greater value, which is 4 plus 2, which is 6, and -1, which is 5. Right? You can't directly just add 4 and 2, right? You can't do that. So right now we update this with a 5 because 5 is greater than 4. Perfect. Now when we move forward our I to 1. Now when we move forward our I to 1, we see that again this is greater. So this becomes 6. Right? This does become 6, and 6 is greater than 5, so we update this to 6. Right? Perfect. Now, when we move forward, we see that we go to I, our I is equal to -1, we'll change this to a 1, right? We change this to a 1, right? And 6 is not going to make a difference. It's not going to do anything. And when we go forward to a 4, right? When I go forward to a 4, it'll give me a +5 as our output. So if I would have taken this subarray, this complete subarray, if you see it, if I add 4 plus 2, 6, plus 1, 7, plus 4, 11, and I minus 5, 11 minus 5 is -6, and this will be -5. So this will be 5 plus 5 total. Right. So this gives me a lesser total than this small subarray, which is 4, -1, 2, and 1. Right. So this is going to give me a lower value than this subarray combined. Right. So this is basically what Kadane's algorithm is, and I really hope you guys understood why what's happening is happening. Right. If it does go below 0, you just need to understand that we are only gonna store a value in maxi, right? If it's just like -2, right? The whole question is an array of -2. Just need to realize that we're going to store maxi. Firstly, we're going to do the very first step, which is have the sum. Then we'll check with the sum with maxi. And because from minus infinity and minus two is greater, we'll change maxi equal to -2. And even if the sum does go below zero in this case, we'll still return maxi, right? We're not returning the sum, we're returning maxi, which is -2. And you need to realize that a single element, -2, will have a greater value than any combination of negative values combined, right? And we are keeping the positive values present because let's say if I have a 4 over here, right? I'm subtracting -1. I can't just remove this subarray, right? Just because it has a negative value present in it. You can't just remove it because me adding a 2 and 1 over here later on in the next two sequences is just increasing the value of the total output, right? So if I had something like 4 -1 2 and 1, right? My currently, for me, 4 would be the greatest value, right? Next step, I subtracted, it reduces the value. But when I move forward to a 2 and then I go to a 1, which would be 3 plus 2 4 5, and 5 plus 1 6. The 6 would be the greater value, right? And me having any small subarrays like 2 plus 1 will be 3, 4 minus 1 would be 3, 4 2 and -1 would be 6 minus 1 5, right? All of them would be still lesser than the whole combination combined, right? That is why when we have positive value, if the value isn't positive, we're not changing anything and reducing it to zero, because there's a chance that the next values could be positive. In this case, where the next values are positive and these two next values does increment the whole subarray's total value, right? So this is what the question of maximum sum subarray is, and this is how Kadane's algorithm works, guys. I really do hope that you guys understood my whole approach. If you didn't understand anything, do let me know in the comments below. Let me know if I can do anything to teach you guys the concepts better. And yeah, this is the code for Kadane's algorithm. Have a look at it once. This is Kadane's algorithm's code. And yeah, let me just change this to minus infinity. Actually, you don't need to change to minus infinity because in the very first case, you're anyways keeping maxi equal to, what do you call it? The very first value itself. But for just the sake of it, I'll just change this to float of minus infinity. But you can also keep it to the very first value of this nums array, because it's not going to make a difference, because as you know, in the very first step, you're adding the sum, and the sum is getting compared with maxi, and it's eventually gonna be greater than maxi, which is infinity. So it doesn't matter. You can just keep maxi equal to the very first element of your array. But let's just run it over here like this. It is running, and let's just submit this. Yeah, it's submitted, guys. And this is the time complexity for this code, guys, is going to be O of n, and the space complexity is going to be O of 1. Yeah, that's it. And yeah, guys, if you like the video, like, share, and subscribe. Do let me in the comments if I can do anything to teach you the concepts better. There's like a 10% coupon code for a Geeks for Geeks course below. You can check that out as well. And yeah, guys, until next time, thanks.